This video, I want to talk about how you're going to determine what size shock absorbers to use on your vehicle. So in order to do that, we need to know the actual force that's going to be applied. So here's a process you can use. First of all, determine all the weight that's going to be supported by the suspension, and start with the frame and any attached parts. So you see this little picture here. This is what we're looking at. Take the motor off, take the wheels and tires off of it, take the seat off, would be my advice. And you can do that on SOLIDWORKS or Inventor. Will determine the mass properties. Then we're also going to look, also I put the jack shaft stuff on there. Also do the engine separately, because you can look up the actual weight of the engine. The model that we're using is kind of a solid model. It's not going to give you an accurate value. So look up the weight of your motor and then determine the maximum weight of the rider that you want to have on this vehicle and use a reasonable number. Don't use 500 pounds. Don't use 50 pounds unless it's for a little kid or something. Then we're going to draw a free body diagram of the frame, looking at those forces. We'll sum moments around the supports and find the force on each of the axles. And then we'll use that force when we draw a free body diagram of the swing arm to find the force in the shock absorbers. To find the weight of the bare, I call it the bare bike, but again, taking the motor off, the wheels and tires, the seat off of there, and pretty much leave everything else. The thing about the wheels and tires is that's unsprung weight. That's below the suspension. You probably could leave that swing arm on there, but not the rest of the stuff. In SOLIDWORKS, you just look up the mass properties. It'll tell you my frame is, everything you see here is 42.38 pounds approximately. So you can do the same with the Inventor. So draw a free body diagram of the complete bike. So at the front tire, I've got my reaction at the front. That's where the tire touches the ground. And my rear tire, I've got the reaction where the rear tire touches. Those are unknowns for us. Now the things we do know is the weight of the frame. I just determined my frame weighs 42 pounds. I rounded it off. Now this is a small bike. It's for kids. So I'm going to set the max at 100 pounds. And I'm going to put them on the center of the seat. Frame, I'm going to put it in the center of the frame. Just kind of approximate that, where that's really going to be. And then the motor, I looked up my motor, it's 50 pounds. You need to check your motor. Your motor is different than mine, and I put that on the shaft center line there. And then I need these distances, and I need to know where they are from one of the endpoints, one of the reactions there, so I know where everything is happening force-wise and dimension-wise. Now what I'm going to do is solve for those reactions. So here's my free body diagram. I took the motorcycle out, but this beam represents the bike. There's my front, and there's my rear. There's my rider, my frame, and my motor, and the same distances I showed. So if I sum moments around here, and I can solve for the reaction at the rear, and that turns out being the force at the rear is 131.73 pounds. I sum moments around the rear and solve for forces here just to verify that I was good and to find that value there. That turns out to be 60.27 pounds. Then to check, I sum forces in the y direction. Remember, this is an equilibrium. That's not moving up and down while it's sitting there. So the downward forces and the upward forces have to be equal. So I sum the forces in the y direction, and they do equal 0. So the force on the rear axle is 131.73. Force on the front axle 60.27. What we care about now is the rear axle because we're looking at the rear shocks. So now we'll do the swing arm, do a similar thing with the swing arm. Look at your swing arm, get your actual dimensions for the lengths. Now remember, this is a small one, it's for a little kid's bike. Now our supports are going to be where this attaches to the frame, and then here where the shock absorber attaches. And this is really what we're looking for, is the force on the shock. This is our known value that came from what I just did a second ago, where I calculated the force on the rear axle was 131.7 pounds. So that came off of that frame. So now I can sum moments and find the force on the shock. Same thing, sum moments around A and solve for that unknown value there. That turns out to be 164.63. Now I always like to go and sum moments around the others. Sum moments around B now and do the same thing, and it turns out the reaction at A is 9, which seems low. Remember, it's just pivoting on this point right here. And same thing, sum forces in the y direction, and make sure that it equals 0 to check yourself. What I end up with is approximately 165 pounds on the shocks. So in conclusion, when I choose my shock absorbers now, I just want to make sure that they can support a minimum static load of 165. Now static would mean sitting still. When it's moving, obviously it's going to have more force. It'll have more force applied to it. It'll have to be stronger, but 165 is a good starting point. So typically you might double that and say I'm looking for something that's got like 300, 350 pound capable force in it. That way you don't have a shock that's so weak that the bike collapses when someone sits on it, or it's so stiff that it has no suspension whatsoever.